Okay, David. Although we're going to discuss your views on solar geoengineering, can you start by broadly putting into perspective how you see effective policy unfolding on emissions reduction, carbon dioxide removal, and then solar geoengineering?
Well, so for emissions reduction, which is really the whole action on any timescale that matters, I think the crucial thing is to begin implementing what we have seriously. I work on things that are innovative. I've been involved in a startup company, but I think that while innovation is important, we have a lot of technologies to begin the process of really driving emissions towards zero. And I think the crucial thing is to begin deploying them in a way that's really serious. And I see this as fundamentally a country by country fight with some international coordination. And I'm really, I've been involved in climate for 30 years. I've heard lots of promises and I've, lots of disappointments. And I think that the last couple of years, I really think that the rise of the youth climate movement, for whatever reason, it seems that climate really has become more politically salient, which is thrilling. And I do credit the rise of the youth movement quite a bit, Greta and all the other people like her. And I'll say, actually, so I'm Canadian, and there was an election here a year ago that was one of the first elections kind of in a Western democracy post the kind of rise of the climate youth movement. And climate rose to be arguably the top issue on the Canadian agenda. By polling, it was number 2. And to be clear, climate usually, even when a lot of people are talking about it, people like you and me, climate's normally number 10. So it rose to be number 2, and it was a complicated fight and divided government, but the parties that supported radical climate or strong climate action really won decisively. And my sense is the Conservative Party here, which has been kind of tied to oil interests, even now, it's not decisively fighting the kind of amazing carbon price. We have supposedly a carbon price that will go to $170 a ton by 2030, which is really world leading. And I mean, maybe just to keep talking about that, this is a bigger deal than you might think, because Canada, while Canada likes to think of itself as liberal and green, it's actually very hard for Canada to make deep reductions because we are much more dependent on oil and gas and on heavy industry than many other small Western democracies. So the pain is going to be real. I'm speaking to you from Alberta, my long-term home, and there's no question that people will lose their jobs and livelihoods as the oil industry goes down. And so that's a real economic hardship. To be clear, I think the oil industry has to go down, but I also feel for my neighbors. And I think that that does give me some sense that maybe we are getting more serious in the climate fight. But the hard part is yet to come, because I mean, right now the easy part in a way is installing solar and wind at the margin, and it's been fantastic. But really deep decarbonization requires some kind of big industrial policy, which is going to be tough.
In the time that we have available, is emissions reduction enough? Does the carbon dioxide removal space, is it really viable? Is it going to deliver what we need it to deliver? What are your views on those two sort of things together?
So one thing is just, pick on you a little bit in an academic way. I think you said enough or, in time, and that, presupposes there's some kind of objective answer about what's enough. And I think it's really important to say there isn't. I think there's been a lot of framing politically, for good reasons, framing around the 1.5 report and the idea that we have a fixed carbon budget. But even the authors of that report had been careful to make clear that that wasn't a scientific conclusion. I mean, that report was answering a policy question. There's no question that the climate science tells us the more CO2 in the atmosphere, the worse we're off. No question about that at all. But it's not that there's a sharp threshold. And the idea that there's a fixed carbon budget is, wonderful for negotiating policy, but it's just not true scientifically. And nobody who's a competent scientist says it is. So I think that's important to just be clear about. I think carbon removal fundamentally is going to be important for reducing the amount of CO2 in the atmosphere once emissions are down towards zero. I think that for the first at least half or maybe 2/3 of the job of cutting emissions, it's going to be cheaper to cut emissions than to emit the carbon and recapture it. So carbon removal may be important for that last third or something, but that last third's a long way away. And I think a big lesson about policy is you don't make decisions and plan before you have to. So I'm thrilled about developing technologies for carbon removal and about testing them with commercial scale development, so we start to drive down the costs. But I think the idea, which is now popular in the carbon removal sort of hype industry, that we must have X gigatons by X date, that's made up based on integrated assessment models tied to the 1.5 report, which again are not a basis for sound policy.
Okay, and on that principle, do you think you kind of remove this moral hazard of, well, if we're removing all the carbon dioxide, we can carry on
Well, no, I think the
slower?
moral hazard is quite acute, actually. I think that in fact, partly carbon dioxide removal looks easier because people aren't thinking seriously about who pays and what the environmental consequences. So I think now people begin to look seriously at what deep emissions cuts look like. People begin to see how hard it's going to be. And carbon removal is this thing that isn't quite there yet. I mean, it is real, to be clear. Technically, it's doable, but it's not happening at large scale. So it's easy to imagine that this technological thing that allows us to do something in the future helps. But no, I think the moral hazard is absolutely real because carbon dioxide removal is sort of a perfect moral hazard. It's basically saying, if you've been promising your mom that you'll clean up your room every day for a year, it's like saying, okay, no, I'm going to solve my promise to do it today by saying I'll really clean it up 4 times next week. And unless there's some underlying dynamic that makes that true, that's real, it's just moral hazard.
And now, if we talk about solar geoengineering, it seems to get the most attention in the mainstream media with regards to approaches to sort of or responses to climate change. You're involved with the ScopeX project, which itself is in the media. Can you give a broad overview of how this form of geoengineering could be effective?
So ScopeX is just a tiny experiment related to one little piece of solar geoengineering, but solar geoengineering could be effective could be effective if you put, say, reflective aerosols in the upper atmosphere. That would be done in a pretty, I think, if it was ever done, it ought to be done in a way that's pretty even, north to south and east to west. And it's clear that technically that it's doable. I think everybody broadly agrees about that. And the evidence from really all climate models and from other analogs is that if one did it in combination with emissions cuts, that the climate risks might be reduced in ways that they could not be reduced by emission cuts alone. So there's evidence, I think quite strong evidence actually, that solar geoengineering could reduce human suffering and environmental harm, say before 2050, in ways that would be really not achievable by emissions cuts alone. I mean, for example, it would be possible to keep global average temperatures under 1 degree C by 2050 in a way that I think is well, it's clearly not achievable with emissions cuts. I mean, to be clear, because even if you cut emissions to 0 tomorrow, you can't do that. You'd need a time machine.
What you're saying is that there should be a point in the timeline, whenever that happens to be, where you would deploy this technology, given the checks that it actually works, and you've done all the research, that you deploy this technology with an objective to bring the temperature down. And that's, I just wanted to firstly contrast that with some of the other voices out there that say, oh, well, this is a kind of technology we have on the shelf that we use if everything else failed, this kind of emergency technology. What's your view on that? Because that's a different...
I don't understand what that means. I've never understood a coherent view of that. What would it mean for everything else to fail? So emissions reductions can't fail. Emissions reductions is a social choice. It's not like we're going to, like suddenly we find that all solar cells have a 1-year lifetime and stop working. I mean, I guess that just seems so implausible. I don't know what it means. So I don't think so. So I don't know what it would mean for emissions reduction to fail. That's a choice. It's like saying,
what if there was
my room failed?
But what if there was an unexpected spike in global temperatures, and then people said, "Okay, we need to do something about this urgently. Geoengineering we've got this technology. Let's deploy it."
So I think that's I'm very skeptical of. Okay, that's a clear question. I agree that's a clear question. I don't think solar geoengineering makes much sense in that case, because if you truly don't expect or understand the spike, that means you don't trust your theory. And if you don't trust your theory, then you have no reason to trust that solar geoengineering would work to reduce it. So my view is that, I mean, that's a little bit extreme, but basically I don't buy, and to be clear, I think most of the community agrees with me now. So early on, people talked a lot about this emergency framing, but hardly anybody in the solar geo research world does it anymore. And my view is that if it makes sense, to be clear, I think there's legitimate views that we should never deploy it, and we don't know enough. But I think if we deploy it, we should deploy it slowly, ramping it up slowly to reduce the average climate risks. And I think the idea of a kind of red button, if there's an emergency, hit the button deployment is really it may in practice be what people want to do because that's the way human nature is. But I think it's ill-advised because when you deploy things really suddenly in a rush, you have less chance to monitor for ill effects, for mistakes, for errors, and you have less confidence in the results.
Okay. And I think this leads us quite nicely into you to be able to explain the risks from your research and from how you perceive it. But before we do that, can you talk a little bit about the criticism that you've seen in the media from about ScopeX that you might find pertinent in terms, I agree with that, or incorrect or unreasonable?
So there's been quite a bit of criticism in the Swedish media, but I don't read Swedish, and I feel like I don't understand exactly what the dynamic is. So I'm hearing secondhand from different parties about what's happening, and I may be incorrect. But I believe there have been claims that that our experiment violates international law, and that the only reason we're doing it in Sweden is because we were not allowed to do it in the U.S. And those claims are like laughably false. It doesn't violate international law. People are referring to this decision by the Convention for Biological Diversity, but that decision actually explicitly endorses research. You check my Twitter feed and check the actual read the text of the CBD decision, and it also explicitly allows for small, purely scientific experiments. So that statement's really false, and it's just completely false that we didn't do it in the U.S. because of anything regulatory. We didn't do it in the U.S. because there's actually a very limited number of high-altitude balloon operators in the world. And SSC, the Swedish Space Corporation, turns out to be a fantastic high-altitude balloon operator. We've been really happy with them technically. They found actually some technical problems in our experiment we didn't know about. And for complicated reasons, Raven Aerostar, who we were working with, they had subcontracted the launch for the particular payload weight class that we had. This is purely technical stuff. And that launch provider had itself gone out of business. So there wasn't, our US provider simply couldn't operate the launch. So that's why we ended up talking to the Swedish Space Corps. I think those are two criticisms. I'm happy to, if you want to raise some more, I'm happy to try and respond.
Well, one I thought that was sort of probably the most obvious from what I would see is that it provides a slippery slope argument that once you start the research, you're ultimately going to deploy. And what would you say to that?
So one simple answer is that there's empirical evidence that it's not true. So there are plenty of other places where people have done research on analogous technologies, and the research has shown that technologies don't work very well, and so the research has ended and they haven't been deployed. So a good example of that is actually related to this, ocean iron fertilization. At the very beginning, this was the idea that you could add tiny amounts of iron to the ocean and stimulate oceanic productivity and remove carbon from the atmosphere. The early claims were super impressive. There were a series of very careful modeling experiments done, ocean geochemical modeling, and some physical experiments. And the result of all those experiments is it's pretty clear that it sort of doesn't work. You can stimulate plant growth locally, but you don't get large-scale exports of carbon to the deep ocean at a scale that makes sense. And so interest in that has largely gone away. So there are lots of examples where people have an idea for a thing that appears to be potentially useful, and we do research and we find it's not useful, and so we don't do it. So the idea that there's a one-to-one link between anybody's early idea and research automatically leading to deployment is just false. There's tons of counterexamples.
Okay, and based on that, because another sort of version of this is the precautionary principle. Technology got us into the mess, so we shouldn't use technology to get out of it. I'm sort of paraphrasing another argument.
Yeah, so I think that is just incoherent. The fact is that like it or not, in a world with 7 billion people, not using technology is not an option. I mean, if you truly don't use, I mean, what does technology mean? Does technology mean an ox pulling, do agriculture? I mean, if you truly mean not technology, then the carrying capacity for the planet for people might be well under a billion, might be only a few hundred million. So you've got to kill 90% of the people. That's just objectively true. So I think that claim makes, I mean, as you said, I'm just teasing you, that
Yeah.
claim is I mean, either it's an incitement to mass murder or it's incoherent. Um, the fact is, humans, I mean, the protein in our bodies depends on Haber-Bosch processed nitrogen. We now make industrial nitrogen in a larger quantities, or basically the same quantities nature does. That might have been a policy mistake. Maybe we should have done something different. But to stop now would literally condemn people to starvation. That is just a fact.
Okay. And this is, again, you're now getting into these sort of equity issues. And this is
Exactly. And I
another
notice
one
it's
that,
mostly rich people making this claim,
yeah.
and they wouldn't suffer very much. And it's the poor people who would. So there's some deeply weird ethical issues here. I mean, a year and a month ago or so, year and 2 months ago, I was invited to Bangladesh to speak on solar geoengineering. And indeed, some people in the sort of left-wing environmental movement criticized them at the Congress of the Parties for even inviting me. But their attitude is they have an equal right to control these technologies. And when you talk to people, we went outside to talk to some farmers in the Delta region of Bangladesh. These are people who literally their farms will be underwater in maybe even at the end of my lifetime, certainly my kids' lifetime. And the probability of people dying from heat is very high. And the idea that somehow we should not think about technologies where we have a lot of evidence that those technologies could help those people strikes me as kind of ethically dubious.
Yeah. Okay. That's interesting. Can we now talk about the real risks that you have seen in which concern you about the technology?
Yeah. Sure. So again, to be clear, these are risks about deploying the technology, which are very different from risks of early experiments.
Absolutely.
So there's a whole huge list of risks. There are a bunch of physical risks. So any individual way that one actually did what we call radiative forcing, reflected more light, would have risks. So for stratospheric aerosols, it could deplete the ozone layer. It could may actually have ways that it would increase high altitude clouds as the aerosols, anything you put in the stratosphere is going to eventually make it to the ground. So it might actually make more high altitude clouds, which would undo the effect completely. When those aerosols get to the ground, you have to worry about ground level air pollution. There's all sorts of worry about unexpected climate effects, whether doing this actually makes the climate worse in some place. There's then a whole series of political worries. I mean, the central concern I think most people have, that I certainly have, is that these technologies will be exploited by political forces that want to block emissions cuts. Basically, big oil companies or petroleum-rich states will exaggerate how well these technologies could work in an effort to block emissions cuts. I think that's a central risk. There's no question there's a whole bunch of risks. But it seems to me that our job, if we're trying to have ethical debate and public policy, is to be transparent about what we know about the benefits and risks.
If we were in the point of deployment, or we were deploying and it was turned off, this is quite often cited as a huge risk, that if it was turned off, you would see very quickly a spike in temperature.
Let me go a little further actually on the oil company one first. I think it's important to take the next step on the chessboard and think it through. So I don't think it's an if. I think there's no question that at least some people in oil companies or oil-rich states will say, hey, we've got solar geoengineering, we don't need to cut emissions so fast. I think that's likely to happen. But it's not like the rest of us will suddenly do what they say. But the reality is this is a political battle with many of us on the sort of environmental left on one side who are fighting for emissions cuts, and we're fighting against parties that want to have slower or no emissions cuts on the other side. That battle's been going on for a long time. It's a hot battle. And then there's a middle ground who just doesn't care that much, rather just get on with their day, right? And the question is, solar geoengineering isn't going to change the fact that you or me, I'm guessing your politics and mine too, really want to see deep emission cuts. It won't change our views. And it won't change the views of some people who are climate deniers that we shouldn't have emissions cuts. The issue really politically, you got to think a step further. How would it actually change the political debate with the kind of median voter, which is what would actually determine the outcome? And I think we don't know. But I think it's important to actually think this through. I mean, just saying some oil companies will exploit this, well, oil companies exploit all sorts of bullshit. That's their job. But it doesn't mean that we listen to them. Politically, you have to make an argument this is really going to change what happens. And maybe it will, but you got to be more sophisticated. And I'm not saying you personally, but people who are concerned, you can really think through what it means. The termination risk is something that I personally don't worry about that much, and I think that's for political and technical reasons. So the way it's often stated is, if somebody just turns it off, well, why would somebody just turn it off? I think the answer is there's all sorts of technologies where if somebody just turns it off, we're done. That's true for electricity. It's true for nitrogen production. If somebody just turns off nitrogen production, to go back where we were earlier in our thing, we're done. There's in fact a whole host of technologies that we completely depend on, where if we just turn them off, there's mass starvation and death. Lots of them much worse than any effective solar geoengineering. To be clear, if you do solar geoengineering the way I'm sort of suggesting, might make sense, of sort of a watt or two per square meter mid-century, turning that off would have effects that would be visible, but they would be much less bad than turning off lots of other technologies we have. And there's no motivation I can see for turning it off. So you need to really think through a scenario that's coherent and makes sense.
Okay, well, in a kind of related, but not quite switching off, but what about weaponization, where the models tell you could impact someone's agriculture, for example? Are these real risks that you model and look at, or that you consider?
I've certainly considered and worried about them. I think I was one of the first people to write about them, actually. So in an article I wrote in 1990, I wrote about weaponization, although there was actually earlier concerns. So there's no question. So I'm a pretty skeptical about the military person, and I think I'm absolutely worried. I think we've had a lucky break, which is there are technologies that in principle could work for geoengineering, which would be useful to the military. But so far, all those technologies seem to be too hard to do, and we don't actually know how to do them. And the technologies we actually know how to do, which is stratospheric aerosols, seem useless to the military. And let me explain why, because this is a technical reason. This isn't because of goodwill on the point of militaries. It's because of just a technical luck, if you like. So the technology we most know how to do, putting aerosols in the atmosphere, in the stratosphere, they last for 2 years or so, and they inherently spread all the way around east to west. And so in the end, technically, it turns out you only have 2 or 3 knobs to adjust. You can do equator versus pole a bit, and northern hemisphere versus southern, and that's it. And what militaries want is they want weapons that cause relatively acute harm in an acute area. And it just doesn't do that. There's no way to make stratospheric aerosols just go over one area. There are theoretical technologies, like if you had a low Earth orbiting mirrors that reflected away sunlight, where you could reorient them in a minute, then you could have weather control, and you could, blot out the sunlight over one area, and that really would be a military weapon. And there's movies about this, Geostorm, for example. But luckily, those technologies seem, they're essentially science fiction at this point. They would cost trillions of dollars, and nobody's developing.
Okay, so it's not a precision tool, and this kind of plays into the unilateral country who says, okay, say the Middle East country said, I just want to cool our little bit here. What would be the outcome of one country saying, we're going to do it because we can afford it, we've got a plan?
So I think that's really worth thinking about. So the way I think about it, I don't assume everybody has goodwill. I assume that countries are in fact self-interested and selfish. But I think the question is to think through the really motive. So let's say one country says, we just want to cool ourselves, screw everybody else. There isn't a technology that we have today, as I was sort of saying, that just cools one area. Well, the technology we most have are global stratospheric aerosols that inherently are pretty even. Now, let's say that technology is that country is in the northern hemisphere. Maybe you would argue that they would prefer to just do the northern hemisphere. But then that will make all sorts of other countries a lot worse off along the equator. And countries, while countries may want to be unilateral, countries think about the impacts, and there's some game theory that people think about what their opponents will do. And I think the question is, since there's no big advantage to doing it just for your country, why would you do it as some hypothetical jealous, self-interested country in a way that harmed others, when you could essentially just as easily do it in a way that was globally beneficial? Because there's no reason to sort of create a fight you don't need to have. And so that's why I think there's reason to hope that, which I don't means you shouldn't worry. I think there's some reason to hope that this could actually be done in a way that was reasonably globally beneficial.
Okay. And what are the research sort of hoops you have to jump through now, in terms of, if you were looking through a series of things that you really need the answers to, can you sort of give a broad outline of what they are?
Sure, but I think I really want to take the me out of it. I mean, so I think right now a very realistic worry is that this is a inbred clique. It's been called the geo clique of a few researchers who think this is a good idea. And to be clear, to the extent that's true, nobody outside should trust us. You should only trust science when there's really been many independent groups doing it from culturally and geographically different backgrounds who really are critiquing each other. That's the only way we end up trusting science. So my view is that it would be ridiculous to make decisions about deploying geoengineering now. I think also ridiculous to ban it forever. My view is that we need a much broader research effort, and an effort that has, I'm really talking about I'm not giving you the scientific answer, I'm happy to do that, but I think the process matters the most. The only reason that somebody should trust this in the end is if there's several different groups around the world that are trying to develop specific methods to do this in a way that's transparent and public and not for profit, where all data is open, and then many other groups trying to find out all the ways those groups are wrong. Only after you've done that for a while should you trust the results. And that's much the way we do vaccine trials, right? We don't just trust a vaccine trial because somebody says they got a great vaccine. We trust it because independent people look at the data and look for problems. So same issue. So I can tell you a lot about what we need to do. I think the central thing about trust is about process.
Okay, well, let's go back a step to getting a major research project off the ground. Because unlike a vaccine, people see the need and they're like, yeah, sure, put the money into that. With this, it seems to be, from the mainstream media perspective, much more difficult to get. Am I wrong there? Is how much confidence?
I think in a sense you're right, but it could tip easily. The mainstream media can tip. It has moved on this. There's been there's much more credibility for these technologies than there was 5 years ago. We've got multiple national academy reports. We've got IPCC. There's lots of ways in which the thing looks more credible than it did. And there's more interest in research. There are more research programs. I mean, there are now research programs in India, in China, in Brazil, in Norway. There's a EU priority program. There's the US programs. They're all tiny, but they're there. They exist. And that wasn't true a decade ago. So it is true that the mainstream media is I think, and I think what's my maybe slightly incendiary or pushing you critique is I think let me say the most incendiary thing. I think there's been well-intentioned bias. I think that many people in the climate science community are sensibly concerned about the slowness of climate action and sensibly worried about the self-interested, ugly power of oil companies blocking action. And many people who report on climate feel the same way. And there's been a bias to assume that solar geoengineering is something that's bad, and that bias is because of concerns about this moral hazard. But I think the bias actually doesn't reflect, to the extent that we know at all, what people think. So there's a really interesting study that there have been several studies that have tried to probe more what randomly selected scientists think, or what randomly selected humans think about these technologies. And my broad view of those results are that people and randomly selected scientists are more supportive than you read in the media. We just did a study, and to be clear, you might think I'm biased, but this is with colleagues who have a long track record of expert judgment work, where we used a set of randomly selected US IPCC authors. So we just took a list of all authors and did random draw, and same in China. And we asked them about solar geoengineering research. And I think all but one wanted a significant research program. And the average wanted a research program as big as 5%, that was the median answer, of atmospheric science research. So that is radically different from what you'd read in the media. And yet that was a random draw of IPCC authors.
From a personal perspective, as someone who talks a lot to people about climate in the UK, I always get the opposite sort of end. I always see a much more anti. And it leads me to think that how much confidence do you have that if people looked at the benefits versus the risks and the kind of what you see in terms of when you look at all of the research that's been done, how much confidence do you think you have that they would then say, okay, this deserves a full-scale research program?
I don't know. It's a really hard question. I mean, I think this gets back to a bunch of other issues that are at the intersection of technology and the environment, where I think there are really different views, and I think I'm on the more, I think I'm on the more environmental side, but obviously probably both sides do. So issues about organic farming and the use of technology in agriculture, issues about some use of genetic technologies as substitutes for chemical insecticides. There are cases where some, especially European environmental groups, have opposed those technologies. I think their opposition was deeply misguided and has harmed the environment and harmed poor people in the developing world. But I think they're very similar issues. So, as you know, there's this broad, and maybe it's worth saying, I come from a family of environmental scientists. My father helped to get DDT banned. I'm very acutely concerned about those issues, and I grew up doing research on those issues. But I think the idea that we shouldn't, that the right answer is hands off, is in fact an anti-environmental answer at this point. Because my view is, if you want to preserve the natural world, we need to reduce the human footprint, reducing it physically and reducing it chemically. And if you really did do what some, I think, European enviros suggest, which is to do everything in a more lower tech, primitive way, given the actual number of humans on the planet, you would have a bigger environmental impact, not smaller. I think that people, though their heart is there in terms of environmental protection, they're not honestly advocating the things that would most protect the natural world that we all hold so dear.
I think more engagement between these groups, between different opinions, is what's really needed. I think we need much more dialogue.
I'll tell you one little anecdote that might be fun. It's been really in my head because we just had some conversations a week ago. I've been thinking of writing a piece. So one of my strongest critics, a colleague and friend called Ray Pierre-Humbert, is keen on calling what I'm doing environmental hacking. And they say that we're hacking the planet. So I actually want to write an article that says environmental hacking is a family business. And there's a funny trick of language, because my parents were involved in getting DDT banned and then in reintroducing peregrine falcons, which is a kind of falcon that was killed by DDT. And when falconers, when they reintroduce birds, do what's called hacking. That's the actual word. We were just talking with my father's stepmother about this because somebody's writing a history about this. So I helped to build a hack box when I was 13 in the 76 or something, where we were breeding falcons artificially, that is at an artificial breeding facility in Alberta. And then the falcons were being released in Eastern North America to reintroduce them to the wild. And to me, there's a quite interesting analogy, which is that you needed both things. So if you so the peregrine falcon reintroduction program was messing with nature. It was like geoengineering, but it was messing with nature to try and preserve nature, not to make something different, to try and protect it. And just like geoengineering, you needed to both reduce the underlying problem and do the technofix. So the underlying problem was DDT. If you just done the technofix, if you just reintroduced the falcons without banning DDT, it wouldn't have worked because the DDT was killing them. But if you just banned DDT and hadn't reintroduced the falcons, it also might not have worked. That was the conversation we were having with this person who's writing a history with my father and stepmother, because the population was so far down, they might not have been able to naturally rebound. So my view is that it is possible, and there are examples. There's a thoughtful writer who calls this anthropogenic but not anthropocentric. So it's anthropogenic in the sense that it's technology coming from people, but the goal isn't just for people. We weren't reintroducing those falcons for some human benefit. We were reintroducing them because we love falcons. We want the natural world to be more the way it is. And my view is that there's a certain real disconnect about solar geoengineering, where people are so keen in their political battle against the oil companies, which I share. I've been in the middle of that battle, that they're losing track of the fact that there's an actual world out there in the high Arctic, where I've traveled a lot, where we are going to lose it, and where technologies like this could really help protect it. We could, with solar geoengineering, keep temperatures under 1.5 with confidence, and we could prevent loss of the big ice sheets and keep the Arctic more the way it is. I think that's a pretty high value thing. And I think it's important that people not get lost in their sort of political battle where the oil companies will say X, and lose the idea that they should advocate for humans having less footprint on the natural world.
Well, look, David, that's an excellent place to end the conversation. But thank you very much. It's been very insightful. And
thanks a whole lot.
I do hope it gets more discussion.
I think that's the biggest thing. I think to end there, I think what we need, I think, and thank you for doing this. And I think the thing that we need is more transparent discussion. I think that this is genuinely a hard topic, and thoughtful people, I think to be clear, I think there are very well-considered reasons to oppose ever using these technologies. But I think that some of the reasons people use are in fact not honest. And what we need is a more honest, transparent dialogue about what the real risks and trade-offs are. And anything any of us can do to forward that dialogue would be helpful.